Okay, deep down in the tiny, invisible world of atoms, there's this epic battle going on all the time, and it literally shapes everything around us. So today, we're diving right into this great electron showdown, ionic versus covalent bonds.
See, the thing about atoms is they kind of hate being lonely. They're always looking for a way to be more stable, so they almost never just hang out by themselves.
They bond, right? They form these connections that create the molecules making up our water, the air we breathe, and yeah, even you and me.
But here's the question. Are all these bonds created equal? Oh, not even close. The difference really comes down to, well, you could almost call it atomic personality.
On one side, you've got the thief. These are the atoms that just straight up steal electrons from others. And on the other side, you've got the partner, the atoms that believe sharing is caring.
And this idea right here, this is the whole ball game. A complete transfer versus an equal share. A heist versus a partnership. You get this one core distinction, and honestly, the rest just clicks right into place.
So first up, let's talk about the thief. An ionic bond is pretty much a high-stakes electron heist. One atom gives an electron away, another one grabs it, and this powerful attraction is born from the chaos.
Now, for this heist to work, you need two very different players on the field. You've got a metal atom, who's our generous giver, and a non-metal atom, the taker, who's more than happy to snatch that electron. The classic example? Good old table salt, sodium chloride.
What's so cool is how this whole thing unfolds in three simple acts. First, there's the loss. Sodium gives up an electron and becomes positively charged. Then, the gain. Chlorine swoops in, steals it, and becomes negatively charged. And finally, the attraction. Those opposite charges pull them together like super strong magnets. And boom, that's your ionic bond.
It really is that straightforward, you know? One gives, the other takes, and that powerful force of attraction handles the rest. That's pretty much the entire story of an ionic bond, right there.
All right, now let's switch gears and meet our second character. This one builds a totally different kind of connection. Welcome to the world of covalent bonding, where it's all about the power of sharing and good old-fashioned cooperation.
And here's the huge difference. It's all about who's involved. In a covalent bond, you've got two non-metal atoms teaming up. And since they're pretty similar, neither one is strong enough to just steal an electron from the other. So instead of fighting over it, they cooperate, forming really stable molecules, like the oxygen we're all breathing right now.
This really gets to the philosophy of it. It's a genuine partnership. The atoms share their electrons so that both of them feel stable and complete. There's no transfer, no ions with crazy charges are formed. Nobody really wins or loses. It's all about that mutual benefit.
Okay, we've met our two contenders, so now it's time for the final showdown. Let's put the transfer and the share head-to-head and really see the key differences side by side. And this table just lays it all out so perfectly. For ionic bonds, you've got a transfer of electrons happening between a metal and a nonmetal. It forms charged ions, and you usually end up with a solid. But for covalent bonds, it's all about sharing, happening between two nonmetals. No charges formed, and you can get a gas, a liquid, or a solid. Look, if all this chemistry talk is getting a little fuzzy, just remember this simple analogy. An ionic bond? That's like one person just giving all their money to someone else. Sure, there's an attraction there, but there's also a clear power imbalance. A covalent bond, on the other hand, is like two people pooling their money to share everything. It's an equal partnership. And really, that brings us to the ultimate takeaway from all this. Ionic bonds, they're built on the drama of transfer and attraction, while covalent bonds, they're built on the quiet strength of sharing and stability. So I'll just leave you with this little thought. In the world of chemistry, and maybe even in life, which one do you think is ultimately more powerful? A bond that's forged from a dramatic, powerful attraction, or one that's built on a quiet, stable partnership? Definitely something to think about. Thanks for tuning in.